Hey friends, welcome back to your channel on JEE Physics. For last few days, could not upload the videos due to health issues. So here we are restarting again. We'll bring in some amazing concept. We'll discuss some very interesting concept today, keeping a very close view on the preparation of JEE 2026. I hope you will enjoy. So let's start. So here we are going to see the concept of angle of contact in a totally different perspective, right? So for that, what we are going to take, there is some liquid in a container as you can see. And here on the container, there are three interfacial tensions. These are called interfacial tensions. As you can watch out here, SSG, S represents solid, G represents gas. So this is the interfacial tension. This tension I'm talking about is the interfacial tension between the solid gas boundary. And in the similar way, this is the surface interfacial tension on the liquid gas boundary. And this is the interfacial tension on the solid liquid boundary, as it is tangent everywhere, so accordingly the directions are matched. Now if I take the component of this, you can clearly check that the component of SLG in this direction will become how much? It will become SLG cos theta. In this direction, the component will become SLG sin theta. So SLG sin theta is going to be counterbalanced by the adhesive forces, since we are considering that the liquid molecule at that particular point in this corner is at rest. And in the vertical direction, if we put summation of Fy is equal to 0, we can check that S of Sg should be equal to S of Sl plus S of Lg cos theta. From here, you can check cos theta is coming to be S of Sg minus S of Sl divided by S of Lg. Now that's pretty interesting, very interesting equation, because it will help us to have a different perspective of angle of contact. How? Let us check. If I want to discuss the case 1 over here. So case 1 thing is that if SSG is greater than S of Sl, but S of Sg minus S of Sl is less equal to S of Lg, in that case cos theta value will be less equal to 1, and in that case theta angle will become acute angle. It will be less than 90 degree. So in that case, the surface that we are thinking about, the surface should be concave downward, right? Earlier, if you remember, we have studied all these cases by considering adhesive force is greater than cohesive force, or cohesive force is greater than adhesive force. But this is completely a new kind of thinking, which is allowing us to have a better understanding of the angle of contact. Case 2, if you want to check, I will consider the same thing. S of Sg is now less than S of Sl, but S of Sl minus Sg minus Sl is less equal to S of Lg. In that case, the cos theta value will be negative. Cos theta is negative, matlab theta is going to become obtuse, and then the surface that we are having will be concave upward, correct? Now the thing is that if you take these interfacial tensions SLG, SSL and SSG, it is said that all of them, if they can form a triangle, like if this is the liquid molecule we are taking, in this liquid molecule, if you take this is S of Sg, and two other interfacial tensions are there. This is S of Lg and this is S of Sl. If they can form a triangle, then definitely the liquid will be in equilibrium, and such triangle we call Newman's triangle, correct? Now let us understand a little better, and from this concept of interfacial tensions, I will slowly go into the capillary rise. So here, as you can check, along the capillary tube, in the upward direction SSG is acting, downward direction SSL is acting, right? So if I think about the work done, so there is a work done by these two interfacial tensions when there is a capillary rise of H. So how much will be the capillary rise? I mean, what can I calculate? Work done by interfacial tensions is equal to, what can I write? We can write S of Sg minus S of Sl. Since it is going up, surface tension into the length will be equal to how much? 2 pi r. So this is going to be the force value into how much height climb is H, right? So this is the work done by the interfacial tensions. There are two more work dones. One is the work done by gravity. That is very easy to understand. Work done by gravity. For such kind of system, we use the equation mg into y center of mass. That is pi r square h rho g, y center of mass will be equal to h by 2. Now the condition is that there here we assume that the liquid level rise up very slowly. That means acceleration is equal to 0. So acceleration is equal to 0 in the sense that means there is a work done by the viscous force on the wall. Viscous force along the wall. Correct? So now the question is that how can we calculate this work done by the viscous force on the wall? So for that I have taken a diagram, as you can check. In this diagram, look at here. You look at this portion. I'm assuming there is a small segment. So this segment is of having thickness dx. It is at a height of x from the free surface, h by x from the top. So if it is moving with zero acceleration, then definitely viscous force is balancing the weight of the liquid column. Which liquid column we are talking about? We are talking about this liquid column. How much will be the liquid column weight? Pi r square h minus x rho into g. Correct? So Fv is equal to this now. Now if I want to calculate the work done by this one, how can I do it? I will do in this way. dWv is equal to Fv dot dx. So I'm going to write pi r square h minus x rho into g dot dx. So work done by this is equal to pi r square rho g h minus x dx. Integration will be from 0 to h. So pi r square rho g, directly I am writing this is going to become h into h minus of h square by 2. So this is pi r square rho g h square by 2. Very interestingly, you can check this is exactly equal to this value. This is exactly equal to this value. So that means whatever the work the interfacial tensions is doing, half of that work, this much work, basically where it will be done, this work done by viscous force over here along the surface, pi r square rho g h square by 2, this will be used to raise the temperature of liquid. This will raise the temperature of the liquid. Now if I want to check this, work done by interfacial tensions is equal to work done by gravity plus work done by viscous force. There is coming how much? Pi r square rho g h by 2 into 2. 2 gets cancelled. What is the work done by interfacial tensions? We have earlier. This value is this much. That is equal to S of Sg minus S of Sl, right? 2 pi that into 2 pi r into h, that is equal to pi r square rho g into h square. 1 r gets cancelled, pi gets cancelled, 1 h gets cancelled. Acha, earlier this value SSG minus SSL, from this equation SSG minus SL is equal to SLG cos theta. So you can write SLG cos theta into 2 is equal to rho gr into h. You will get a very interesting equation. 2 SLG cos theta by rho gr. Come on, amazing. This is nothing but capillary rise, right? So this is another way of looking into the in-depth points of surface tension. I hope you have enjoyed this video. I hope you have liked the content, and I hope, sincerely pray that it will enable you to have deeper perspective into understanding or tackling the questions from here. If you like the content, don't forget to like, share and subscribe. Thank you so much. See you in the next video. Bye-bye.